Welcome to day 5, 8.4 compound interest. This is our second day on it. We're going to focus on finding present value. So what do we need to deposit in order to accrue the future value that we want? Okay, so last section we talked about the future value, right? With compounding interest, n times per year. So today what we're going to focus on is actually finding the present value that we need to actually deposit in order to get that future value. So all we're going to do is we're going to manipulate, and we are going to solve for the p-value. So hopefully you recognize all we have to do is just divide by this whole quantity. So p is going to equal that a, our future value, divided by 1 plus our rate, divided by the number of compounding periods, n, all raised to the n times t. Now, it's again very important that we're using parentheses correctly. So it wouldn't hurt to put an extra pair of parentheses around that entire denominator. So make sure as you're going through the notes, you are trying the calculations on your calculator, all right? Then we also need to talk about how we find the present value when we're compounding continuously or infinite compounding periods, okay? So again, you should recognize, well, in order to get p by itself, all we need to do is divide that a by that e to the rt. Okay, so again, use parentheses around that entire denominator. Now, one key is when we're computing that present value or what we should deposit, we want to make sure we're always rounding up to the nearest penny, all right? And I'll go through an example showing if we don't round up what happens versus when we do round up. So let's jump to this first example here, all right, where we ask how much needs to be invested so that 40 years from now, there's $50,000 in the account. So 40 years, that's our T, right? $50,000, that's our future value. That's how much we want. This 8.9% interest, there's our R. And then compounded monthly, that's our N, right? So we're just going to plug into that present value formula, all right? So plugging everything in, and I would put parentheses around the entire denominator. Now, over to the right here, you can see what your calculator should tell you. So your calculator should tell you 1440.74416, okay? But remember, we round up, so our answer is going to be 0.75, all right? Now down below, you can see, right, if we were to not round up, and if we were to use that present value of $1,440.74, would we have enough money in our account? So using that future value formula, you would see that we only have $49,999 and roughly 85 cents in our account, which is not $50,000. Versus if we are using the rounded up version and that 75 cents, using our future value, you will see that, hey, we do have $50,000 in our account at the end of 40 years, and that's what we want. Now we're going to look at the same concept, only this time we're going to compute when it's compounded continuously. So remember, when we see compounded continuously, we're thinking of that PERT formula, okay? So how much needs to be invested today? That's our P, right? 40 years, that's our T. So that there's $50,000 in the account, that's our future value. We have our interest rate of 8.9% compounded continuously. So when we see that, we're thinking PERT. So now we're going into that formula. When you are doing this, put parentheses around that entire denominator, all right? And double check that you are in fact getting $1,421, and again, rounding up to 95 cents. If you were to look on your calculator, you would get this value over here, okay? You can check on your own to double check that, if you didn't round and you said 94 cents, would you have enough money in your account after 40 years? Versus if we do round up to 95 cents, do we have enough in our account? So double check that. It's good practice with your calculator and with your formulas. All right, before we move on to the last example, that's going to deal with effective annual yield. Okay, the last thing we're going to talk about in this section is called effective annual yield, all right, or effective rate or simple interest rate. Those are all kind of intertwined and used to represent the same thing. So there's lots of different investment opportunities out there. Some have higher rates, higher risks. Some are compounded continuously, annually, monthly, etc. So the question is, how do we compare these? How do we know which one's better? Okay, so one way we can do this is we can compute how much is in the account at the end of 1 year and report the simple interest rate that would have yielded the same account value. So we're talking about something called effective annual yield. Okay, this effective annual yield allows us to compare the different investments and actually see, well, which one's a better bang for our buck if we're investing, or which one's going to save us more money if we're taking out loans, etc. Okay, so effective annual yield is the simple interest rate, okay, that produces the same amount of money in the account at the end of 1 year. All right, as when the account is subject to compound interest. All right, so when borrowing money, this is usually called the annual percentage rate, APR. So you'll hear this if you're buying a car. What's the APR? All right. Otherwise, it's called our effective annual yield. Okay. All right, so the formula for this, y is our new variable, all right, is equal to 1 plus r over n raised to the n power, all minus 1, okay? So the nominal rate is that stated rate. So you'll see what this looks like in our example here. So let's quickly take a look. All right, so a couple takes out a loan for a house with a 5% interest yield, right? Compounded daily. So remember, we use 360 days for a year. So here's our rate. This is our N, right? When you go to sign the paperwork, it says the annual percentage rate is 5.13%, all right? Why is that? So if we're looking at the effective annual yield, right, we're using our effective annual yield formula, which is what we just saw up above, okay? And what we end up getting is this guy right here. Oops. Okay. So the effective annual yield. So go ahead and just compute that. But now let's digest this and see what it's really referring to, okay? So what this means is that money that's invested at 5.13%, because that's what we get here, this comes out to be 5.13%. That's how we're talking about that, all right? Simple interest. So if we convert this to simple interest, right, it's going to earn the same amount in 1 year as money invested at 5% interest compounded daily. All right, so what we're doing is we're looking at this information up above, okay, and saying, okay, if we were to convert that to simple interest for 1 year, what would this simple interest rate be? Okay, so that's the effective annual yield there, and that's how we compare it to the compounding multiple times per year. If you have questions, let me know. We will go through anything. For now, you are working on day 5.